Hi, this is Mr. Frazier, and I'm introducing the material to you for 13.1. Let's understand that 13.1 is still basing off the entire principle we learned in Chapter 12, which was, can we factor or find the x-intercepts of a polynomial, or what they call the roots. Okay, so remembering that when we're factoring, that only gets us to the part where we can find the answer. A lot of you in the last test, you had a hard time because you would stop here. You would factor a polynomial, which is fantastic, but the roots are the number that you used. So, for example, when this was x plus 2 and x minus 1, the roots would be negative 2 and positive 1. But many of you left your answer here saying this was the root. Unfortunately, this is not the root. This is factored form. You pull those numbers out and they become the roots. If you wanted the x-intercepts, you could do this. So when it came to the answers, I did allow some people to write them out as a point. But remember, these are all x's. Okay? They're not y's. Some people wrote them backwards and it didn't count. Well, a lot of times we can't factor a polynomial. In other words, we're going to do some math in our head and we ask what multiplies to a number or adds or subtracts to the middle number, and you can't do it. Okay, meaning the numbers are decimals and it's in your head and you can't figure it out. So we've come up with something called the quadratic equation. The quadratic equation lets us factor any polynomial. So we can factor all polynomials. In other words, this actually works for every problem we ever do. The issue becomes it takes time. Whereas factoring is relatively easy. We read the problem and divide everything and talk backwards. This requires you to take the numbers in the original expression or problem, so like 3x squared minus 10x plus 15. We would have to take these numbers and we manipulate them into an equation. The equation is the opposite of b plus or minus, because we're always going to have how many answers? 2, correct? Because we're looking for where it crosses the x-axis, and a parabola has to cross twice. Sometimes it can cross once, but that would mean it was perfectly squared. All right, so b squared minus 4ac all over 2a. So in essence, you can start with a problem like this, and then you just plug in the numbers and do the arithmetic. But it does require you have a calculator. And the two problems will look identical, except for one you will add to the square root and one you will minus the square root. That's what this symbol means. You're going to do two problems. But you'll start out looking like you're only doing one. So in this case, our a is our a term. The b is our b term. And our c is the last term. And you plug them in. So this says I need the opposite of b. So when I put in my number, you can see it would be the opposite of negative 10, or two negatives make a positive. But I'm just plugging in numbers right now. And this is what it's going to ask you to do in Carnegie as well. Then b squared, okay, minus 4 times a times c. Okay? Everything good so far? And then we divide it all by 2a, which would be 2 times 3. So done relatively easy, so that you can see that, oh, I take out the letter and plug in the number with parentheses. And that tells me what I need to multiply, keeps my power straight. This becomes a positive 10. This becomes 100 minus, and then of course 4 times 3 times 15. 4 times 3 is 12, times 15 is correct. So I'm waiting for you to get your calculator out. Hopefully you do so. So this would be 180 all over 6. As I do it, I then split it into two problems. I have 10 plus the square root of negative 80 and 10 minus the square root of negative 80 divided by 6. And there's where I create my two problems. Now, you should realize this is going to be an issue because you can't square root a negative, and at this point we would say that there are no roots for this problem, meaning it's not touching the x-axis. Okay? So let's change the problem a little bit so that we don't have that issue. And I'll do this, 3x squared minus 10x plus 1. Okay? So here I'm doing my second problem, and now I'm using numbers that are a little bit more, that will give me some additional math to do. So it would be negative 10 squared again still, or the opposite of negative 10, plus or minus the square root of negative 10 squared minus 4 times 3 times 1 all over 2 times 3. Whoops, I was going to put the answer. 2 times 3. Okay, now I go through and do the very simple math. It's 10 plus or minus the square root of 100 minus 12 over 6. And now I split it into two problems. So it ends up being 10 plus 88 square rooted divided by 6, and 10 minus the square root of 88 all divided by 6. Notice two problems. Then I do the square root of 88. Hopefully you know that that's 4 and 11. Okay, square root of 4, 4 and 22. So the square root of 4 is 2, square root of 22. And over here it will be 10 minus 2, square root of 2 divided by 6. And if they wanted it in simple radical form, I'd be done. If they want it in decimal form, I just hit equal, and it tells me what each decimal would be. This would be my x-intercepts on my graph. But this is the part where you would use the calculator for. Now, many of you may not be able to do the square root of 88 into perfect squares, but it's 4 and 22. All right? And this is all you're doing in 13.1. Over and over and over again. All right. Thank you very much.